All right, students. In this video, we'll continue our work with adding fractions and subtracting fractions. The rules for subtracting are the same as the rules for addition. We need common denominators. In number 1, for a common denominator, since 6 and 7 are consecutive numbers, I know to multiply them together. 6 times 7, that's 42. Now, if you can get the numerators without showing any work, great, do it. What do you multiply times 7 to get 42? Is 6. We'll multiply the top by 6. And what do you multiply times 6 to get 42? Is 7. We'll multiply the top by 7. See, if you can get 30 and 7 without writing the red part down, that's where we want to get to. For a final answer, keep that common denominator and subtract the numerators. 30 minus 7, that's 23. There's the proper way to show your work. Write the problem down, rewrite it with common denominators, add or subtract the numerators. Try to do the red part in your head. In number 2, we're adding and subtracting with multiple fractions. Let's get ready. But I know I need a common denominator. A common denominator means a number that 4, 2, and 5 can all divide into. 2 goes into 4, but 5 doesn't. 2 and 4 both go into 8, but 5 doesn't. 2 and 5 both go into 10, but 4 doesn't. I need a number that they all go into. Well, 4 and 5 go into 20. 2 also goes into 20. I think 20 is the number I want. 20 is the smallest number that 4 divides into, that 2 divides into, that 5 divides into. Now we get the numerators. What do you multiply times 4 to get 20? We'll multiply by 5. What do you multiply times 2 to get 20? Multiply by 10. What do you multiply times 5 to get 20? Multiply by 4. Now keep the common denominator and add and subtract left to right. So it's 15 minus 10 is 5 plus 8 is 13. Great. From time to time, variables like m and x are going to creep into our fraction problems. Here's how to deal with them. We're adding fractions, so I know I need a common denominator. 5 and 6 are consecutive numbers, so I know to multiply them together. Now get the numerators. What do you multiply times 5 to get 30 is 6. And 2m times 6 is 12m. What do you multiply times 6 to get 30 is 5. And 5m times 5 is 25m. Now keep that common denominator. And since this has an m and this has an m, these are like terms and I'm allowed to add them. 12m's added to 25m's is 37m's. That's exactly the way we want number 3 to look. Here comes number 4. Common denominator first. Well, I notice that the small denominator divides evenly into the big denominator, which means the big denominator is a good common denominator. What do you multiply times 4 to get 8? Is 2. What do you multiply times a number to get itself? Is 1. Now 3x times 1 is just 3x. keep the common denominator, but uh-oh, that doesn't have an x. That does have an x. Those are not like terms, so I can't really combine them. The best I can do is show in my answer that I'd like to combine them. I'd like to take 2 minus 3x, but they're not like terms, and I'm not allowed. So we'll leave the answer just like that. In number 5, we have a whole number minus a fraction. Let's rewrite this problem so that both of them, the 1/3 and the 9, look like fractions. We'll make 9 look like a fraction by putting it over 1. A whole number can be turned into a fraction so long as the denominator is 1. Now when we subtract fractions, we need a common denominator. Well, I noticed that the smaller denominator divides evenly into the bigger denominator. So the bigger denominator is a good common denominator. For the numerators, what do you multiply times 1 to get 3? And what do you multiply times a number to get itself? Now keep that common denominator and subtract the numerators. 27 minus 1, that's 26 over 3. Beautiful. Let's try that again. It's a whole number minus a fraction. We'll rewrite the problem showing 2 as 2 over 1. That way both numbers look like fractions. Now a common denominator. Since the smaller number divides evenly into the bigger number, we'll use the bigger number. Numerators. What do you multiply times 1 to get 7? And what do you multiply times a number to get itself? Now keep the common denominator and subtract the numerators. Beautiful. All right, your turn. Go work some homework. I'll see you later on today.